Today we are going to learn the stack data structure. A stack is a linear data structure that follows a particular order in which the operations are performed. It is a data structure that follows the last in first out principle. It behaves like a stack of plates where the last plate added is the first one to be removed. In a stack, there are two operations are made, push and pop. The insertion is called as push and the deletion of elements are called as pop. In a push operation, the elements are inserted into an array. Let us consider the data structure as array. Then the elements are pushed one by one in the stack. The last element which is pushed is popped first. So the stack follows the last in first out. See in the figure we can see the example. The element A is pushed first and the element B and the element C. So the last element inserted is C. We can delete the element C first, which is in the top of the stack. So the next element to be deleted is B and then A. So the stack follows the last in first out data structure. The key operations on data structure stack are push, pop, peek is empty and is full. Push operation performs, that is, it adds an element to the top of the stack. The pop operation removes the top element from the stack. The peek operation returns the top element without removing it. Then the condition, if we want to check whether the stack is empty, then the is empty operation is made. And then is full is used to check if the stack is full. The application of stack data structures are recursion, expression evaluation and parsing, depth first search, undo or redo operations, browser history and function calls. These are the various applications of stack data structure. Using the stack data structure, we can perform these applications. We can implement the stack using array or linked list. If we use an array, then the elements are stored in an array. First, the array should be initialized to represent the stack. Use the end of the array to represent the top of the stack. Implement push, that is insertion operation, and the pop, that is removed from the end, and the peek to check the end operations, ensuring to handle empty and full stack conditions. Before pushing the element to the stack, we check if the stack is full. If the stack is full, then we cannot insert an element. So we have to check it first. If the stack is full, the top is equal to the capacity minus 1. Then the stack overflows and we cannot insert the element into the stack. Otherwise, we increment the value of top by 1. That is, top is equal to top plus 1. And the new value is inserted at top position. The elements that can be pushed into the stack till we reach the capacity of the stack. See in figure, first we are having the empty stack which is having the top element as minus 1. Then we are going to insert, in the next figure we can see, that is we are going to insert the element in the array, that is the position 0. In position 0 we are going to insert the top element, that is the top value is 0 here, and we are going to push 1 number in the 0th position. So push element 2 into stack. So 2 in the first position and then 3 into stack, that is stored in the second position. Then element 4 in the third position. The stack has only 4 elements. So the next we cannot insert the element 5 into the stack. So the condition is called here stack overflow. So 5 cannot be inserted because the top value is 3 here, and then we can make the pop operations in stack. Before popping the element from the stack, we check if the stack is empty. If the stack is empty, then we cannot delete the element from the stack. So that's why we are checking. If the stack is empty, that is the top is equal to -1, then the stack underflows and we cannot remove any element from the stack. Otherwise, we store the value at top, decrement the value of top by 1, then top is equal to top -1 and return the stored top value. Here we can see the pop operations. Initial stock is there. In the stack there are already we have inserted 4 elements. It is from position 0 to 3. The element first popped is 4 because last we inserted the element 4 in the stack. So here we already have seen that the element which is inserted at last can be removed first because the stack follows the last in first out principle. Next we can remove the element 3. So